the unit circle and large angles. In this right angle triangle we have the angle theta, which is acute, so it's in this range, the adjacent side to the angle, the opposite side to the angle, and the hypotenuse. So using this right angle triangle I can work out the cosine ratio for my angle theta using this formula, but I'm restricted to angles which are acute. So how would you work out the cosine ratio for an angle that's, for instance, 200 degrees or minus 30 degrees? How would you generate a graph like this, where you've got large positive angles and you have negative angles? With the right angle triangle we're restricted to angles in this interval 0 to 90 degrees, so we can only generate this portion of the graph. We need an alternative way to define the trig ratios to work out ratios for large angles and negative angles, and this is true for sine, cos and tan. Starting with the x and y axes, this is a unit circle, so it has a radius of 1. I have an angle of 30 degrees. From the positive x-axis, if we go anti-clockwise, we generate positive angles. Going clockwise would give negative angles. In this right angle triangle, the adjacent is 0.866 units, the opposite side is 0.5 units, and the hypotenuse is just the radius of our unit circle, so it's 1. These are the formulae which are commonly used for sine, cos and tan ratios, and substituting these values into these formulae give these ratios for sine, cos and tan. So back to the unit circle, I'm going to place a point on the circumference of the circle here, and now I have the x and y coordinates. We're going to use the coordinates to define the trig ratios. In this right angle triangle, the adjacent side here has a length that's equal to the x coordinate. The opposite side has a length equal to the y coordinate, and the hypotenuse is fixed. It's the radius of the circle, and to make the numbers convenient we use the unit circle, which has a radius of 1. The x and y coordinates can be positive or negative, and we'll use these coordinates to define the trig ratios like this. So for 30 degrees, sine 30 is equal to the y coordinate, which is 0.5, divided by the hypotenuse, which is 1, and that gives us a sine ratio of 0.5. For cos 30 we have the x coordinate 0.866 divided by the hypotenuse, which is 1, giving us 0.866 for the cosine ratio. And then for tan 30 we have the y coordinate 0.5 divided by the x coordinate 0.866, and that gives us a tan ratio of 0.577, and we can do the same for any angle on this unit circle. For 120 degrees we can see that this point has a positive y coordinate, but the x coordinate is negative, and using these values in the new definitions that we've got here for sine, cos and tan, we get these ratios. And for 240 degrees the x coordinate is negative and the y coordinate is negative. Again, substituting these values in to these formulae, we get these ratios. For 330 degrees, positive x coordinate for this point, negative y coordinate for this point. And again, the hypotenuse doesn't change, it's just the radius of the circle. Substituting these values into these formulae, we get the sine, cos and tan ratios.